Scalar multiplication with matrices is simply like the distributive property. We take a number that's in front of a matrix, which we call a scalar, and we multiply each number inside the matrix with that scalar. So for this example on problem 1, we have negative 5 times 6 is negative 30. Negative 5 times negative 5 is positive 25, because a negative times a negative is a positive. And then negative 5 times negative 1 is positive 5. So we just do that process on any problem that we are doing. Sometimes we might be dealing with algebra instead, algebraic expressions. It still works the same way. So like on number 9 here, we would go negative 2b times negative 6ab. That means the negative 2 times the negative 6 would be positive 12. Can't forget about the a, but then the b times the b will be b squared. Negative 2 times positive 4 is negative 8, and then the 4 doesn't have any variables, but we still have the b on the negative 2, which means our answer will include that b. If there were another b, then we would, of course, have a b squared like we did in the first part. Here's another one that's very similar to that, where we're distributing 5b through each of these 4 elements. So 5b times negative 1 is negative 5b. 5b times a is 5ab. 5b times ab is 5ab squared. 5b times a is 5ab. 5b times 2 is 10b. And 5b times 2a is 5 times 2, which is 10. And then we have our a times b. So it's just working with expressions just like they're numbers, because they're just numbers in disguise since we don't know the values of the variables. Sometimes we also combine some of the operations we've learned together. So we previously learned adding and subtracting matrices. So in this problem here, we're adding these two matrices together first in the parentheses. So negative 1 plus 5 is 4, negative 2 plus 0 is negative 2. Then we take that answer and we multiply it by 5. So 5 times 4 is 20, and 5 times negative 2 is negative 10. So in this situation, we actually added first because of the parentheses, and then multiplied that answer by 5. We would not do that on this problem. This problem, we would multiply by the scalar first, and then add the matrices together. Same thing with this one, multiply by the scalar first, then add the matrices together. Let's hurry and do that one. So if we have 2 times 1, that's 2. Oh, you know what? On this one, I want to take the negative with it. That would be better if I do the negative, because then all I'll have to do later is add, which maybe is a little easier. You don't have to do it that way. It's just an idea. So if I go negative 2 times 1, then I have negative 2. And then if I do negative 2 times negative 4, I have positive 8. That way, instead of subtracting, I can just add, which is usually a little bit easier, especially if you're subtracting negatives. So we don't have to worry about a double negative turning into a positive, because we already took care of that negative, turned it into a positive, and now we just add it. So 3 plus negative 2 is 1, and negative 3 plus 8 is positive 5, and we have our resulting matrix. Notice how these matrices were both 1 by 2s, and our answer is also a 1 by 2.